alcohols, phenols, ethers. This is our next topic in organic chemistry. Alcohols, phenols, ethers. Now, alcohol functional group. OH. So, if OH functional group is present at any carbon in the organic compound is called alcohol. If one OH group is present, they are called alcohols. Suppose if two OH groups are present in the organic compound, they are called dihydric alcohols. Dihydric alcohols. Generally, they are also called glycols. They are called glycols. Suppose if three OH groups are present in the organic compound, these are called trihydric alcohols. Trihydric alcohols. They are also called glycerols. They are also called glycerols. If more than three OH groups are present in the organic compound, then they are called polyhydric alcohols. So, if only one OH group is there, then they are also called monohydric alcohols. If two OH groups are present in the organic compound, then those compounds are called dihydric alcohols. If three OH groups are present in the organic compound, they are called trihydric alcohols. These are also called glycerols. And more than three OH groups are present in the organic compound, then they are called polyhydric alcohols. CH3, CH2OH. It is monohydric alcohol. Monohydric alcohol. Its name C2H5. This is ethyl group. To ethyl group, OH group is attached. So ethyl alcohol. Now CH3, CH3. This is ethane. If one of the hydrogen atom is removed, then it is called ethyl group. If two hydrogens are removed from adjacent carbons, then it is called ethylene group. Ethylene group. Now, if two OH groups are present at adjacent carbon atoms, so it is a dihydric alcohol. Dihydric alcohol, and it is very important compound, ethylene glycol. What is the importance of ethylene glycol? This I told you in halo alkanes topic, I think, and also this compound came in +1 hydrocarbons also. It is used as antifreeze. Very, very important question for you. Antifreeze in automobile industry. Automobile industry. Now, suppose in ethane, two hydrogen atoms from the same carbon are removed like this. Then this group is called ethylidene. So if CH3CH, it is OH and OH is bonded to it, it is called ethylidene glycol. Ethylidene glycol. Now, most important point you have to remember, very, 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 very important. See, in any compound, if two OH groups are present at same carbon, if two OH groups are present in an organic compound, then it is less stable or unstable. So, to get stability, it loses water molecule. So, by losing water molecule, it gets a stability and the compound is converted into aldehyde. Very, very, very important. Now, suppose if three OH groups are present at same carbon, is also unstable. So again this compound also gets stability by losing water molecule. Then C double bond O OH. This is the compound formed. It is nothing but carboxylic acid. It is nothing but carboxylic acid. Similarly, in any organic compound, if OH group is present at a double bonded carbon, also unstable. And such compounds get stability by undergoing tautomerism. So in tautomerism, this hydrogen goes to adjacent carbon atom. So then you will get H See here, double bond O like this. So if here hydrogen is there, then you will get aldehyde. Instead of hydrogen, again carbon chain is there, alkyl group is there, then you will get ketone. Aldehyde or ketone you will get. Now coming to these three are very important, you have to remember. Now here ethylidene glycol, this is unstable, does not exist. So even though in chemical reaction it is formed, immediately it changes into acetaldehyde by losing water molecule. It is very, very, very important for you. Right. Now, if OH group is present at carbon in the benzene ring, so OH group is directly bonded to benzene, right? Such compounds are called phenols, phenol or phenols. These are treated as phenols. Clear? If OH group is present at a hydrocarbon chain, aliphatic carbon chain, okay, then these are called alcohols. And if OH group is directly bonded to carbon in the benzene ring, those compounds are called phenols. Now, see, in phenol, this is orthocarbon, metacarbon, paracarbon, orthocarbon. Again, sorry, this is metacarbon, okay? This is metacarbon. This is again orthocarbon. Ortho, meta, ortho. This is para. Right? Now, here, bromine is present at ortho position, then it is called orthobromophenol. If bromine is present at meta position, then it is called metabromophenol. If bromine is present at para position, then it is called parabromophenol. Suppose in phenols, methyl group, particularly methyl group is present, then those compounds are called cresols. Cresols. If benzene ring contains both OH group and CH3 group, then they are called cresols. So simply this is called orthocresol. If OH group and methyl group are present meta to each other, then it is a metacresol. Suppose in phenol, OH group and methyl group are at para positions to each other, then it is called paracrisol. Now, in phenol, one OH group is at ortho position, or otherwise, if benzene ring contains two OH groups, then if they are at ortho position, then compound is called catechol. Catechol. If two OH groups are present at ortho with respect to the two groups, they are at ortho position, then it is catechol. Suppose OH groups are present at meta position, then it is called resorcinol. If OH groups are present para to each other, then the compound is called quinol. Remember, if they are at ortho position, they are called catechol. Meta position, resorcinol. And para position, it is quinol. Now, for example, this is benzene ring, OH group, phenol. One OH group at ortho and one OH group it is para position, then it is called hydroquinol. Hydroquinol. If the three OH groups are present at 1, 2, 3 positions, very important compound, it is pyrogalal. Pyrogalal. I think this compound came in +1. Hydrogen peroxide properties. We studied that compound, pyrogalal compound, in hydrogen peroxide properties. See, sorry. For example, if this is toluene, right? In toluene, at methyl group, one hydrogen is replaced by OH group. So already you know this compound, this compound is, this carbon directly bonded to benzene ring is called benzylic carbon, right? So therefore it is called benzyl alcohol. And remember, these alcohols are called aromatic alcohols. Aromatic alcohols. See clearly, benzene ring must be there in the compound. Number 1, benzene ring should be present in the organic compound. and second one, it must be alcohol. So that means the OH group is bonded to side chain like benzyl alcohol, side chain, or you can say aliphatic carbon. Then those compounds are called aromatic alcohols. See, in case of aromatic alcohols, see for example, benzene ring, CH2, CH2OH. Now, is it phenol or alcohol or aromatic alcohol? It is no doubt aromatic alcohol because benzene ring is present. Benzene ring is there, and also OH group is at the side chain, means aliphatic carbon. This is aliphatic carbon, and to this phenyl group is substituted. So therefore, it is aromatic alcohol. Clear? It is not phenol. It is not alcohol. Treated as aromatic alcohol because properties of phenol are different from alcohols and aromatic alcohols. Remember. So that is why we study phenols separately. So OH group is there, phenyl group is there. So give preference to functional group. Therefore, it is treated as two phenyl groups. Substituent is phenyl, 2 phenyl, ether, in 1 ol. This is IUPAC name of the compound. Now, what is the name of this compound? See, first carbon, because we have to give preference to OH group. Phenyl group is always substituent only. Second carbon, and this is third carbon because we have to select the longest carbon chain. So, at second carbon, phenyl is there. So, 2 phenyl, 3 carbons, prop, in primary suffix, secondary suffix, ol, because in IUPAC system, the OH group name as secondary suffix means functional group, OL. Suppose if it is treated as a prefix, means substituent, then its name as a prefix is hydroxy. If this is treated as substituent, name as a prefix is hydroxy. If this is treated as a functional group, so secondary suffix according to IUPAC nomenclature is ol. CH2 double bond CH. This group is called vinyl group. CH2 double bond CH OH. This is called vinyl alcohol. But it is unstable. Why it is unstable? Because OH group is bonded to C carbon involved in double bond. Therefore, it is unstable. See carefully. C hydrogen, hydrogen, double bond, C hydrogen, OH group. Okay, CH2 double bond CHOH. So this is the hydrogen bonded to oxygen, acidic hydrogen, or you can say proton. Proton shifts to adjacent carbon. At the same time, pi bond shifts to oxygen. As pi bond shifts to oxygen, hydrogen which is bonded to oxygen goes to adjacent carbon. Then we get H, C, H. This is H here and single bond now. Here double bond O and this is H. So it is nothing but CH3 CHO, acetaldehyde. IUPAC name ethanal. Ethanal. CH2 double bond CH, CH2 OH. See, this is sp2 carbon, sp2 carbon. This carbon is called allyl carbon. OH group is bonded to allyl carbon. Therefore, it is called allyl alcohol. Now, is it stable or not? It is stable. Why? Because OH group is not bonded to double bonded carbon. OH group is bonded to sp3 carbon and that carbon is bonded to sp2 carbon. So therefore, here OH group is not directly bonded to C double bond C. So therefore, this is stable only. Okay. Monohydric alcohols are classified into three types. Primary alcohols, secondary alcohols, tertiary alcohols. See, if OH group is bonded to primary carbon, that means it has only one carbon, then it is called primary alcohol. If OH group is bonded to carbon bearing two other carbon atoms, then it is secondary carbon. If OH group is bonded to secondary carbon, then they are called secondary alcohols. If OH group is bonded to carbon bearing 3 other carbon atoms, then it is tertiary carbon and compound is called tertiary alcohol. So like this, alcohols are classified on the basis of OH group bonded to type of carbon atom. If it is bonded to primary carbon, it is called primary alcohol. If it is bonded to secondary carbon, it is called secondary alcohol. If it is bonded to tertiary carbon, it is called tertiary alcohol. For example, CH3, CH2OH. So here OH group is bonded to this carbon, and this carbon having only one carbon, therefore it is called primary carbon. So it is a primary alcohol. So ethanol, CH3, CH, OH, CH3. See, this carbon bonded to 2 other carbon atoms. Therefore, it is secondary carbon. Therefore, it is secondary alcohol. Because OH group is presented secondary carbon, therefore it is called secondary alcohol. And what is the name of this compound? Propane 2-ol. Because 1, 2, 3, second carbon ol is there, right? CH3, COH, CH3, CH3. Now, this is the carbon bearing OH group, right? This is bonded to 3 other carbon atoms. Therefore, it is a tertiary carbon. So, OH group is bonded to tertiary carbon. Therefore, it is called tertiary alcohol. Now, 1, 2, 3, but one methyl group is there, second carbon, right? So, therefore, 2-methyl propane 2-ol. This is the IUPAC name of the alcohol. Now, observe carefully. In all these compounds, OH group is there, therefore they are alcohols. But alcohols are of 3 types. Depending on the nature of carbon atom, OH group is attached. So, see carefully here, primary alcohol, CH2OH. This is primary alcohol functional group. CH2OH. Clear? Now, see, secondary alcohol. This is CHOH. This is secondary alcohol functional. Next, here bonded to 3 methyl groups, right? OH group. So this is treated as tertiary alcohol functional. So all are alcohols only. CH2OH group is present in primary alcohols. CHOH group is present in secondary alcohol. and COH group is present in tertiary alcohol. So OH group bonded to carbon, having two hydrogens is primary alcohol, having one hydrogen is secondary alcohol, having no hydrogen is tertiary alcohol. Now CH2 double bond CH, CH2OH. See, this is allyl alcohol. This carbon is bonded to only one carbon. So therefore it is a primary allyl alcohol. CH2 double bond CH, C, for example, one methyl group is there, then OH group is there. This is allyl carbon, but this carbon is bonded to two other carbon. Therefore, it is called secondary allyl carbon. So therefore, this alcohol is secondary allyl alcohol. CH2 double bond CH, CH3. For example, and one more hydrogen is also replaced by methyl group. So this is allyl carbon only because it is bonded to double bond carbon atom, allyl carbon, but bonded to three other carbon atoms. Therefore, tertiary allyl carbon, and this is called tertiary allyl alcohol. Tertiary allyl alcohol. Okay. Now, alcohols, general molecular formula CnH2n plus 2 O. Alkanes formula with one oxygen, then it becomes alcohol. Or structural formula, general structural formula can be represented as ROH. ROH, general structural formula. Alkyl group, OH group, right? Next, IUPAC name. IUPAC name is alkane and the last letter E is replaced by the secondary suffix for OH group is ol. Therefore, these are alkanols. This is IUPAC name of alcohols. Now, if N equal to 1, CH3OH, first only one carbon. So, this is methyl group, this is alcohol. So, therefore, it is a methyl alcohol. IUPAC name, one carbon, meth, N, O. N equal to 2, CH3, CH2, OH. Ethyl group, ethyl alcohol. Now, eth, two carbons, single bond, N, last letter E is replaced by O. Ethanol. N equal to 3. CH3, CH2, CH2OH. This group is called N-propyl group. So therefore it is called N-propyl alcohol. N equal to 3 onwards, you have to mention the position of the OH group. First position, second position, third position. So therefore it is prop N1O. Suppose if OH group is present at this carbon, see this group CH3, CH, CH3, this group is called isopropyl group. So this is called isopropyl alcohol. Isopropyl alcohol. So this is prop N2O. This is the IUPAC name. Clear? Write all the possible structures, all the possible alcohols instead of structures, alcohols with the molecular formula C4H10O. Write all the possible alcohols with the molecular formula C4H10O and give their common names as well as IUPAC names. Okay. Now C4H10O. How many carbon atoms are there in the molecule? N equal to 4. N equal to 4 means it is butane. This is N-butane. 1, 2, 3, 4 branched chain compound. This is called isobutane. So CH3, CH2, CH2, CH3. This is primary carbon, secondary carbon, secondary carbon. Two types of hydrogens are there. Suppose if you remove a primary hydrogen, then the group obtained is called N-butyl. Suppose if you remove any secondary hydrogen, then the group obtained is called secondary butyl group. This is N-butyl group and this is secondary butyl group. Now next CH3, CH, CH3, CH3. This is primary carbon, primary carbon, primary carbon. And this is tertiary carbon. Now remove any primary hydrogen. then you will get isobutyl group. Isobutyl group. Now, if you remove a tertiary hydrogen, then the group obtained is called tertiary butyl group. Tertiary butyl group. So simply you add OH groups to these groups, then you will get 4 alcohols. N-butyl alcohol, secondary butyl alcohol, and tertiary butyl alcohol. So we will get 4 possible alcohols. They are N-butyl alcohol, secondary butyl alcohol, isobutyl alcohol, and tertiary butyl alcohol. CH3, CH2, CH2, CH2OH, N-butyl alcohol, butane, 1 mole, CH3, CHOH, CH2, CH3. This is secondary butyl alcohol. This is butane, 2 mole. CH3, CH3, CH2OH. This is isobutyl alcohol. So you will get now 1, 2, 3 propane, 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 1 mole, but methyl group is at second carbon, so therefore it is 2 methyl propane, 2 mole. Last one, CH3C, CH3, CH3OH. This is tertiary butyl alcohol. Now take this as carbon chain, then it is 2 methyl propane, 2 mole, can be represented as like this. Okay.